for today's telecon, so you can follow along, are online at http://go.usa.gov/ these are lowercase, B as in boy, number 9, S as in Sam, Z as in zebra. Go.usa.gov/B as in boy, 9, S as in Sam, Z. And we should have a status report on today's topic that either is posted or will be posted momentarily at that site. First, going to introduce our speakers. They are John Callas, the Mars Exploration Rover Project Manager from JPL, and Steve Squyres, he's the rover project's Principal Investigator from Cornell University, Ithaca, New York. Ray Arvidson, the Mars Exploration Rover Project Deputy Principal Investigator from Washington University in St. Louis, Missouri. We're going to start today with John Callas.
Thank you, Jane. Good morning to those on the West Coast and good afternoon to those on the East Coast. It is now Sol 3,331 in our 90-day rover mission. As mentioned, we're coming up on some noteworthy anniversaries. In 3 days, on June 10th, will be the 10th anniversary of the launch of Spirit. It will be 10 years for Opportunity's launch next month on July 8th. And in January will be the 10th anniversary of landing on Mars, so we're approaching 10 years of uninterrupted surface exploration of the planet. Opportunity's current odometry is 36.6 kilometers. That's put more than 70 million motor revolutions on the rover's drive actuators, and that's about 7 times the manufacturer's life test, so we've been on borrowed time for a while. But as I like to say, it's not how far Opportunity has driven or how long the rover has lasted, but how much exploration and scientific discovery that's been accomplished. So if I could have the first graphic, which is Callas 1. In more than 36 kilometers, Opportunity has driven back in time, moving from the sulfate-rich Lake Hesperian geology at the landing site at Eagle Crater, which you can see on the upper left-hand side of this graphic, down to the older Noachian geology at the rim of Endeavour Crater. You can see our crater hopping trajectory from ever larger craters from Eagle to Endurance, then to Victoria, and now Endeavour. If I could get the second graphic, Callas 2, you could see Opportunity's exploration of Cape York on the rim of Endeavour Crater. The rover is now moving along the rim, heading south towards the next winter haven at Solander Point, about 1.5 kilometers from the current location. There we should find, or hope to find, 15-degree north-facing slopes that should allow Opportunity to remain mobile throughout the winter, which is different from last winter where we had to remain stationary. We'd like to get there by the 1st of August, which is the southern autumnal equinox, and this gives us only about 30 drive stalls between now and then, so we have to be expeditious. Opportunity is in remarkably good health considering her age, especially if you measure that in dog years. The rover's health is essentially unchanged since we last reported. There's been some arthritis in a few mechanisms for some time, but the drive system is performing well. The only new concern is what we call flash memory amnesia that intermittently occurs. It seems to be a wearing out from overuse of one of the flash memory cells. It first appeared back on Sol 3161, and it was last experienced on Sol 3286, so it's been a while since it reoccurred. Right now, it's only an occasional annoyance. It's not a health and safety issue for the rover. We've mitigated most of the impact when it does occur. If it gets much worse, if it happens continuously, we have a potential solution of reformatting the flash file system on the rover. And we had something very similar to this on Spirit some time ago. So with the capability that's still left in this rover and the exciting exploration targets ahead that you'll hear about shortly, we consider it Sol 1 all over again for Opportunity. But remember, the rover continues in this very hostile environment on Mars, where we have extreme temperature changes every day, and the rover could have a catastrophic failure at any moment. So each day is a gift. So at this point, I'll turn it over to Steve to tell us something about those gifts.
All right, well, thanks, John. So I'll start with the first graphic of mine, Squyres 1. This is the blow-up of the trajectory that the rover has traveled that John showed you. And I'm going to be talking today particularly about a rock target called Esperance. Its location is pointed out there. Esperance is one of the oldest rocks that we have ever looked at with the Opportunity rover. And, you know, scientific discoveries, when they're brand new, it's kind of hard to put them into context. But to me right now, I would say what we have found at Esperance has sort of vaulted into my personal kind of top 5 for the whole 9.5-year mission of Spirit and Opportunity. This was a good one. Let's go to my second graphic, Squyres 2. This is a false color image of the Esperance region. This whole thing that you see here is only about 1 meter across, this scene. There's one spot that's circled. It's called Esperance 6, and it's one of the many measurements that we made on Esperance. Esperance itself, if you look at this image, if you start at Esperance 6 and you sort of look off to the left from there, you'll see kind of a raised, bumpy-looking ridge. That's Esperance. It's little. It's like maybe the size of your forearm if you have a kind of small forearm. This was really one of the most technically challenging and one of the most scientifically rewarding targets of our whole mission. This was really, really hard. We did a total of 7 measurements on this rock, and this was tough to do. Our rover's got kind of a gimpy shoulder, so we can't position our instruments the way we used to be able to. This took us weeks. There was a dust storm in the middle of this whole campaign. There was conjunction in the middle of this whole campaign where Mars went out of sight behind the sun. So this was a tough one to pull off. One of the things that makes Esperance hard is that it's lumpy, it's bumpy, it's dirty, it's covered with all sorts of Martian crud, and it was very, very difficult to get into this target and to discover its true nature. And it actually took us 7 tries, sort of getting progressively better and better. And the one that we've labeled Esperance 6 here is the one where we finally managed to get into this target with our rock abrasion tool, get down under the surface, get down under all the dirt and crud, and really learn what this thing is made of. So let's go to my final figure, Squyres 3. This is the money figure. This is the payoff. This shows what we discovered. Now, this is what geologists, geochemists call a ternary diagram or a triangle diagram, and it's a way of plotting a lot of complicated geochemical data in a very simple way. When you look at how a rock changes when water flows through it, there are some chemical elements in particular that hold the most important clues. And there are 6: aluminum, iron, magnesium, calcium, sodium, potassium. Those 6 really tend to hold the most important clues to a process like this. And some of them tend to behave similarly. So calcium and sodium and potassium, they tend to behave similarly, so we lump them together. Iron and magnesium tend to behave similarly, so we lump them together. And so we can produce a diagram like this that just has 3 corners to it. So the way this diagram works, let's say you had a rock that had no iron, no magnesium, no calcium, no sodium, potassium, but it had aluminum in it. A rock like that would plot up at the very top of this diagram, up in the aluminum corner. And then as you add different elements to it, you can plot on this diagram where those elements fall based on the layout of the triangle. So it's just a simple way of visualizing the chemistry of rocks. It's complicated data. Look at it in a simple way. There's a dashed line that goes across that diagram. The rocks that fall below that line tend to be igneous, okay, things like lavas. The rocks that plot above that line tend to be rocks that have been altered extensively by water, and particularly tend to have clay minerals in them. And I'll talk about the importance of clays in a moment. Now, there are 2 black dots on there. One down at the bottom is labeled average Martian crust, and that's what most of Mars is made of. Most of the rocks we've looked at on Mars over this entire mission with both rovers would plot very close to that location. And in fact, most of the rocks at Cape York at Endeavour Crater plot very close to that. At the top, or near the higher up, labeled in black, is a square called montmorillonite. Montmorillonite is a clay mineral. It's a commonly found clay mineral on Earth. It's a clay mineral that has a fair amount of aluminum in it, and it's a clay mineral that you can produce if you interact a lot of water with an igneous rock. Now, those yellow points that you see, those 6 dots, those are the 7 dots. Those are the 7 measurements that we made on Esperance. The first ones that we made tended to be clustered down towards the bottom there, and it's because they were contaminated. They had Martian dirt and stuff on them that was comparable in composition to average Mars. And so we tried and we tried and we tried, and we finally, after weeks of work, we managed to get the instruments onto this target that we call Esperance 6. And that's the one where we managed to actually finally get into it with the rock abrasion tool and get at the true character of this rock. And what you see, and this is the bottom line right here, is that as we get closer and closer to the true nature of this rock, we get closer and closer to that point that's labeled montmorillonite. So what we have concluded is that Esperance is very rich in clay minerals. It may be montmorillonite, it may be other clays. There are many other clays that you could plot on this. But this is powerful evidence that water interacted with this rock and changed its chemistry, changed its mineralogy in a dramatic way. Now, I want to conclude by saying a few words about why clays matter. We've been discovering evidence for water on Mars since we first landed in 2004. What's different here? What's new? If you look at all of the water-related discoveries that have been made by Opportunity over its 9.5-year mission, the vast majority of them point to water that it was at a very low pH. It was acid. We run around talking about water on Mars, water on Mars. In fact, what Opportunity has mostly discovered evidence for in the past was sulfuric acid on Mars. What we have here is a very different chemistry. Clay minerals like montmorillonite only tend to form at a more neutral pH. Okay, this is water you could drink, and so this is water that was probably much more favorable in its chemistry, in its pH, in its level of acidity for things like prebiotic chemistry, the kind of chemistry that could lead to the origin of life. This is the most powerful evidence for neutral chemistry water that has been found by Opportunity, and that's the real significance of Esperance. And at this point, I will turn it over to Ray Arvidson to tell you about what's coming next.
Thanks, Steve. Well, you put Esperance in a kind of a broader context, and John mentioned the fact that we do crater hopping, and the mission for Opportunity has been going into a number of craters with long drives in between. Craters are geologists' friends because they produce the third dimension, the stratigraphy that we're after, the rock strata as a function of time. And Esperance is part of a collection of outcrops that we call Whitewater Lake, very fine-grained, laminated, and from orbital data from CRISM, which is a hyperspectral imager, there's a suggestion of a very tiny overprint of a more primitive clay called a smectite. Esperance is much more evolved, much more luminous rich, which is not surprising because it's in a fracture system where there'd be more water kind of moving through the fracture as opposed to the normal rock. And that's low in the stratigraphic section on Cape York. And as we drove up to the top of Cape York from the region of Esperance, before we went to Esperance, in fact, what one finds is there are breccias, impact breccias. So we may have two different kinds of rocks at Cape York. The problem is we only have a few meters of relief, and we've been mainly driving on the surfaces of the bedding planes. So we want to go to a place where there's tens of meters of relief. So you're like driving along the interstate and you stop at a road section, a cross section, and you can see the whole stratigraphic column. That's where we're going. And if you look at the first graphic, Arvidson 1, we're about, maybe 1,300 meters currently from the next big stop, which is Solander Point. And Solander Point, seen in this perspective view, generated from really exquisite imager on the Mars Reconnaissance Orbiter called HiRISE, where you can do stereo and make perspective diagrams. Solander Point, you can even see from this orbital kind of simulated perspective view, has a lot of strata exposed. In fact, it's tens of meters of vertical section. And what's shown on that diagram, once it comes up, is, Opportunity Sol 3327 was earlier this week, and it's a little bit further in between Sutherland Point and Nobby's Head. We want to be at Solander Point by August because it's interesting geologically. It has more of the section, where we might